So hello everyone, this is lecture 28 for the solid state physics, in which we were studying about the band theory. We already discussed two models, that is Kroning-Penney model and the normal, the overlapping. Now there is this third model, that is tight bonding approximation. So we are not going in detail here because there is no need. So we will see just what is the brief idea of this. It is based on a linear combination of atomic orbitals where each atom interacts only with its nearest neighbor atoms. In the first model, we see that all the atoms can be overlapped and it can be any number. But in the tight bonding approximation, we will take this idea that only the neighbor atoms will interact, okay, or overlap. And we are not solving for all the Hamiltonian and the Schrodinger equation and all. We are just writing directly the dispersion relation which we will get here, that is Ek is equal to E naught minus alpha minus beta summation e to the power I k dot Rn. Okay, just remember this as it is. Now here E denotes the energy in the K space. E naught is the unperturbed energy, where E naught is unperturbed energy level. Alpha and beta are coefficient constants, positive constants. K is the propagation vector and R is the position vector, and N is the number of neighbor atoms, nearest atoms. So let's give you a more idea about this. See, if there is only one atom, then we will have a E naught energy level which is unperturbed, so that is E naught. But when there are the interacting atoms like this, these are neighboring atoms, then their orbitals will overlap and we will see this spreading of band as we already discussed. So this spreading will give us a band of energy. Okay, so when there was no spreading, then we call this unperturbed energy E naught. And because of this spreading, we get this alpha and beta. These are overlap integrals. Means if they are overlapping of orbitals, then we will get the alpha beta. If there is no overlapping single atoms is there, then alpha beta will be 0, and when you put it there, then you will get the total energy as E naught. Okay, now we will consider the 1D and 3D model of this. So let's first see the 1D case. So let's say we have this atom. This is a 1D one dimension. So 1, 2, 3, 4, these are the atoms. So let's consider this one. So it has two atoms interaction, this one and this two. The position vector of this will be ai cap. For this it will be minus ai cap, and they are n equal to 2. So we'll substitute these values in this equation. Here k is nothing but kx I cap, ky j cap. So for the one dimension we will only have the x component. So kx we will write it as k only, and here it is x. So for one dimension it will be E naught minus alpha minus beta n equal to 1 to 2 e to the power I k x n. Okay, now here n is goes from 1 to, there are only two atoms, nearest atoms, so it will be e to the power I x. 1 will be a, and for 2 it will be minus a. So after summation we will get this equation. We multiply and divide by 2 here. First we will get e to the power I k a plus e to the power I k minus a. Now divide by 2, multiply by 2. Now this is nothing but cos ka. You know how to get this. Just try to solve this. Cos ka plus I sin ka, and likewise you will get the cos ka as the answer after solving this. So for one dimension we get this equation, ek equal to E naught minus alpha minus 2 beta cos ka. Now we will try to plot E versus K graph for this, and let's see what we will get. Is it different from Kroning-Penney model or is it same? Okay, now you can see that what happened at k equal to 0. For k equal to 0 this will be 1, and you will get this value. And for k equal to plus minus pi by a, what you will get? You will get E naught minus alpha plus 2 beta. So for plus minus pi by a you will get the maximum value, and for 0 you will get the minimum value. See, for k equal to 0 you will get E naught minus alpha minus 2 beta. When k is plus minus pi by a, then you will get this value, and this is slightly greater than this. So if we try to plot E and K here, then it can't be 0 at k equal to 0, so it will be slightly upper, but it's a minimum value for this, and it's a symmetrical graph, not just this way as it is drawn. It is symmetrical like this. Okay, now for plus minus pi by a we will get this energy, and for this one it is energy this. So you can see that it's just same as you get in the Kronig-Penney model, and this model is better than that model because here we get the simplest equations, and it is very easy to plot the graphs, and this is first billion zone, as you can see. So now let's move forward. Now we will talk about the group velocity. So here just we are talking about the terms. More about these we will study in the quantum mechanics. Here we will see only which is required, or how much is required. We will study only that. So group velocity, you know what is that. We don't need to define that. Just remember Vg is d omega by dk. Okay, and we know that E is nothing but h cut omega. So from here you can find the dE by d omega. That will give you, here in place of d omega it will came out dE. Okay, because t equal to h cut d omega, so here you will substitute, so you will get this value, means Vg equal to 1 upon h cut dE by dk. Now you have the value of energy. What is the value of energy? This is this is the value of energy. Now if we find the dE by dk, what you will get, this is constant, they will turn out to be 0. Cos ka will be minus sin ka, and you will get a outside, so it will be 2 beta a sin ka divided by h cut. Okay, so this is dE, this is Vg. dE by dk is upper one, and 1 by h cut you will multiply, so you will get the Vg this form. Okay, now we will try to plot this group velocity in the curve with respect to k actually. So in the y-axis we will plot the Vg, and x-axis it will be k. So what you will see that at k equal to 0, the Vg will tends to be 0, or if it is plus minus pi by a, then also Vg is 0. Okay, so it's just a simple sine curve we will get like this. This will be the curve at 0 till 0, and for these point it is 0, but it is maximum when it is pi by 2a, somewhere in the middle of this, means when k equal to plus minus pi by 2a, we get the maximum value of Vg, that is plus minus 2 beta a by h cut. Now this is in the 1D. If we talk about in 3D, then we also can find that, means this is nothing but del of E. So delta E by delta kx, delta E by delta ky, this will give us velocity in all the directions, and ultimately we can find the velocity in the 3D. So it's just same. Okay, as we have here 1 upon h cut dE by dk. So it is just if dE by dkx, that will give you in the direction of x, y and z. So this is Vx, Vy, Vz. Now Vx can be written as 1 upon h cut del E by del kx, as I already told you, and Vg is nothing but root Vx square, Vy square, Vz square. So remember these curves and about the group velocity and all. Okay, this is the important thing. Now we will move to the very interesting topic, that is effective mass. Now how we will discuss about the effective mass? Let me tell you, it's not a relativity, means as you study in the relativity that if something moves with the relative speed, then its mass gonna increase and decrease all. So this is different than that. Okay, effective mass is the mass of anything it can be. So to understand it better, we will discuss about the Higgs boson theory. So you can see about the Higgs space and the Higgs field on the Google. You will get a better example. Here I will give you a simple example, or the way I can tell you. So Higgs field is nothing but it's present everywhere in whole space, and when something interact with it, then it provides a mass to that particle. Okay, and that mass is called the effective mass. So it's just a complex theory. Let me give you a better example. Let's say this is a room, or a hall, or amphitheater, and here is a stage, and there are two way into inside. Okay, now see there are a very large number of people, paparazzi and all. Now if a normal person came in and he want to go to the stage, then these paparazzi or the media won't get the attention, means this man won't get the attention of this all, and it can go directly to this here. Okay, so and other than that, if from here Einstein came in, then all the media and paparazzi will come around to the Einstein, and it will take a forever to reach to the stage for the Einstein. Okay, so what I am trying to convey here is that for Einstein the resistance is very large, and for that proper a normal person resistance is very low. So that's how the Higgs field gives the mass, means a particle which is not interacting with the Higgs space or field, then that will get no mass. Like photon don't interact with the any of the space, then that's why we call it as a zero mass. Photon has zero mass. But some particle like electron, proton are going to interact, then that interaction will give the resistance, means the resistance to that particle will give mass to that particle. Means here in the example we'll say that Einstein has more mass because it is getting very much resistance here, and that normal person has zero mass. So this mass which is given by like that, we call it as effective mass. Okay, hope you are getting the idea which I am trying to here give you. So this is called the effective mass. Now let's see what's the effective mass in the quantum, or let's try to find the value of this effective mass. Means electron inside a space have different mass, and if it came in inside a solid or conductor, then it have a different mass. So that mass is called the effective mass of the electron or any particle. Let's try to find the effective mass of a carrier inside a conductor. Let's say we have applied some potential here, and this particular electron inside the conductor will feel the force. Now what will the effective mass of this electron or particle? Force will be what? F equal to ma. So m star represent the effective mass, m star equal to F upon a. Now what is acceleration? Acceleration is dvg by dt. Here it is group velocity. Now we know the value of vg. Vg is nothing but this 1 upon h cut de by dk. So after substituting it here, then we will get this expression, because now E is differentiating with respect to t and k. That's why we are getting d square by e, d square e divided by dk dt. Now multiplying with dk up and down, we will get d square e by dk square dk by dt. Okay, so this is acceleration. Now we need to find the force. Force is nothing but rate of change of momentum, and we know what is p. P is nothing but h cut k. So we'll get this expression, h cut dk by dt. Now just substitute this value and this value here, force and the acceleration. After substituting we get this. It will be h cut square, and this term will be cancelled out, and the denominator will get d square e by dk square. So this is called the effective mass, h cut square divided by d square e divided by dk square. This is the effective mass formula. You need to remember this. Okay, and to understand the more, you should go to the Google and see the Higgs boson theory. That's very interesting topic actually. Now let's try to find the effective mass of the particle we were discussing here. When Vg by this, Vg was this, and so let's see what is dE by dk. dE by dk, from here we can find it with, it is h cut Vg, and h cut Vg is nothing but 2 beta a sin k. This, now we need to find d square e by dk square. It will be this, sin k will give you cos k and a square. Now the effective mass is nothing but h cut square divided by this d square e by dk square. So this is the effective mass. Okay, now what is acceleration? Acceleration, we already find the expression, that is this d square e by dk square dk by dt. We write it here. Now remember this effective mass. Now we will try to plot these effective mass and the acceleration. Here d square e by dk square represents the acceleration. Okay, this is the main thing which affect acceleration. So that's why we're gonna plot this d square e by dk square with respect to k. Now you will see this expression will give you the value, means when k is 0, then what you will get, d square e by dk square is equal to 2 beta a square. So this will be this, means you will get this, and for the plus minus pi by a, what you will get, that will give you minus 2 beta a square. So this will go like this. So this curve you will get for the acceleration, okay, in the k space, and with this d square e by dk square. This will be the plot. Now we will see the effective mass plot. Actually this is the important part, okay, for the effective mass. What is the effective mass? We find out it was this h cut square 2 beta a square cos ka. Now for k equal to 0, we get h cut square divided by 2 beta a square. So for k equal to 0, we get this value, okay, and this is h cut square 2 beta a square. And for k plus minus pi by a, then we will get the minus of this value, it will came out here and here. Now the magnitude of these values are same, these all three, but this is called the bottom of effective mass, and it is called the top of the effective mass. Just remember these terms, these are used very much in the questions. The top and bottom of the effective mass, this is called the bottom and this is called the top, and they have the same magnitude but different in sign, okay. Now what happened at these sides? When it is pi by 2a, then you will get this term, effective mass will tends to infinity, okay. So here when it is pi by 2a, then it tends to infinity, effective mass tends to infinity. So just remember this plot, and we see that when the effective mass tends to infinity, this acceleration tends to 0. This acceleration tends to 0 means the particle will be in the constant state, will not be in the acceleration state when the mass tends to infinity. Then again when it comes to from the minus negative, the acceleration start to decrease in the opposite, increase in the opposite direction, or we'll say decrease. This will go like this. Now just remember this, I already told you this plot is very important. Many questions asked from directly from this plot and this one. So remember these curves, very important. And there is this statement, effective mass can be positive, effective mass can be negative, but it can never be 0. So effective mass can never be 0, just remember this. It is here and here, but it is never touching this axis, okay. So that's all for the today's lecture. We will have 1 or 2 more lectures about the band theory, then we will switch to the crystals. Okay, thank you.